Good morning, learners. My name is Mr. Pochilola once again. We are going to continue with experimental techniques, and so far we've looked at chemical weights, definition, examples of chemical weights, and how you can safely dispose of chemical waste. All right. We've also looked at how you can determine the purity of a substance by melting point and boiling point. If you missed these two videos, please just search in this platform these two videos on experimental techniques. All right, so welcome to how you can determine the purity of a substance by chromatography. The word chromatography comes from the word color. So chromatography has to do with colors. And essentially we are looking at how we can use color analysis to determine whether a substance, especially colored substance, whether it is pure or it's not pure. All right, so in particular, we are going to look at a type of chromatography which is called paper chromatography. Remember that we have different types of chromatography. We have paper chromatography, we have gas chromatography, we have what is called thin layer chromatography, that's TLC. But at this level, we are going to look at how you can use a type of chromatography known as paper chromatography. So by virtue of the name it has, paper chromatography has to do with paper. And in most cases, the paper is called paper chromatogram. Where you use just, you can use the paper chromatograph paper. You can also use what is called the filter paper. As a matter of fact, this paper that is used here is similar to that of filter paper to analyze a sample for its purity, to tell whether a substance is pure or is not pure. Chromatography, all right? So we define, all right, or we can assert to say that paper chromatography is used to separate mixtures of soluble substances that are soluble. And as a matter of fact, in particular, we are looking at the substances that are colored. Substances that are colored. For example, you have ink. You have pigments in different substances. Substances such as chlorophyll. How do you spell chlorophyll again? Chlorophyll is colored, as you might be aware. All these are colored substances. So some colored substances are essentially mixture of two or more substances. Much as some can be deceiving, like for example, when you look at black ink, your black pen, you find that black pen seems to be one color. But upon analysis, you find that it contains more than just one color. So how can you show that a particular given colored substance contains several colors or colored substances mixed up together? So in chromatography, we are saying that substances are picked up and carried by a mobile phase, which moves through a stationary phase. Okay? So we are going to discuss the process of chromatography. Please take note and listen attentively to the terms that are used and applicable in this particular case. So, stationary phase. What is stationary phase? Stationary phase is defined as the part of chromatography which is in solid state. For example, the filter paper. We are going to see soon, in terms of diagrams, what the stationary phase is. And then we have a mobile phase. A mobile phase is part of the chromatograph which is gaseous or liquid state. For example, a solvent. The word mobile means movable. So it is part that moves. Well, this one is part that is static or not moving. Right, so the different solvent substances, rather the different dissolved substances in a mixture are attracted to the two phases in different proportions, which causes them to travel at different rates through paper. So they may ask you to define, rather to describe an experiment that would be done to show that a particular substance is made up of different colors. The procedure, take note, this is an experiment. In paper 2 of your chemistry paper, you may ask you to describe an experiment that could be done to show that a particular substance is made up of different pigments. Just know that you're talking about chromatography. So using a pencil, a start line is drawn near the bottom of the chromatograph paper. Okay, this start line is also known as baseline. It's known as baseline. So a baseline is drawn near the bottom of the chromatograph paper. Remember that the chromatograph paper can be a filter paper or any other paper that is suitable. Having done that, the mixture to be separated is spotted on the starting line. Okay, so let's suppose that we have a paper. This is a paper which is dipped in a solvent. Okay, so a line is drawn just slightly above, right here. A line is drawn there, and then the mixture to be separated is spotted. So you place a spot there. Then the bottom of the chromatograph paper is dipped. The bottom of the chromatograph paper is dipped into the solvent, and the solvent travels up the paper. All right, so over here we have a solvent. Anyway, the solvent used is chosen depending on the solubility of the substance. So remember, this is the sample. So that's our sample, the one that we suspect to be a mixture of several colors, or several different colors. This one here is the paper. the chromatograph paper. So we are saying the bottom of the chromatograph paper is dipped. You dip this into the solvent. Take note, this is the solvent. And the solvent travels up the paper. So the particles of the solvent will rise up. The particles of the solvent will rise up the paper like that. That's the direction of the solvent. So the solvent picks up the substance. So as the solvent is moving up, it will pick up the solvent up like that. Now, there is different components of the solvent, of the substance, rise to different heights. Okay, then the solvent front is marked. So at a particular moment, you will have a solvent front. Okay, and essentially you see different substances, rather different pigments, being picked up from the sample. All right, so the interpretation of the process is that a chromatography is formed. A chromatography is just a pattern formed by substances that have been separated by chromatography. To determine the purity of a substance, the chromatogram is interpreted as follows. A pure substance produces only one pigment. Let's suppose that in the course of chromatography, you have something like this. So this is the paper, all right, which is dipped in a solvent. Remember, a sample is placed here. After the chromatograph process, if you discover that only one spot is formed, then that shows that the original substance is pure. But if two or more spots are formed on the chromatography, then on the paper, it means that the original substance was impure. You'd have something like this being paper. Let's say this is beaker, this is a solvent. This is the original sample, and then you have a sample, a spot, and another spot, let's say several spots. That shows that the original substance was impure. So we're saying an impure substance produces two or more spots on the chromatogram to show that the original substance was an impure substance. But if there's only one spot which is produced on the chromatograph paper, then it means that the original substance was pure. So it's the number of spots that determine whether a substance was pure or was not pure. Very important to note that. All right, so the result could show something like this. So over here, we have a pure substance, rather a starting line, which is a dotted line, and you place your sample here. Okay, so after the process, you find that only one spot, or there's one spot here formed. One spot shall mean that the substance is pure. But for an impure substance, one that has impurities in it, this is the original sample. All right, and after the chromatography process, you find that there are several colors. There's yellow here, there's purple, there's another color there. That shows that the substance is a mixture of two or more components. That's very important to note. I hope we are together there. Another way to tell the purity of a substance is to use what are called relative flow values. Relative flow values denoted by a capital R and an F, which is written as a subscript. Definition: a relative flow value is just the ratio of the distance traveled by the substance, is the spot, to the distance traveled by the solvent. All right. So mathematically speaking, relative flow value, which is denoted by RF. So RF is simply distance traveled by the substance divided by distance traveled by the solvent. All right. So both of the substances, rather distances, are measured from the center of the sample. Okay. So the original sample is right here. Okay, so substance spot B travels up to that point, then you have spot C traveling to that point, and then spot D traveling to that point. So you take the distance, the solvent travels up to that point. This is distance traveled by the solvent. All right, so in order to find the relative flow value, you simply look at each substance or each spot at a time. For example, let's suppose that the distance traveled by the solvent is this one here, all right, and distance traveled by spot B or substance B, if you want, is this 2 centimeters. Then the relative flow value of sample B is going to be 2 divided by 10, which is simply 0.2. Remember that relative flow value is unitless quantity, all right? So relative flow values can be used to identify substances. Let's say you found 0.2 in a formal calculation. Then you go to data. You check data in a book, textbook, and then compare the relative flow value which is recorded in the book and that which you have calculated, and then you tell what substance it is that has that particular relative flow value. Very important to note that. Right, so that's very, very important. So for component B, it's if you go back to component B has a relative flow value of 2. All right, 2. It's not 3, it's 2. Here there's a 2. So that means it's going to be 0.2. That of C is 8. It will be 0.8. And that of D, so for D, if you go back to D has a flow value of 10. Component 10, so you take the distance 10, which is 0.8. So 0.8, you are going to compare that 0.8. This one is here is 0.8. 0.8 over 10, which is 0.8. Over here, I think it's 0.6, like that. So you compare these values with the ones recorded in a textbook. Okay, and then it helps you to identify the substance that has got a similar relative flow value like the one that you just find. So relative flow values, in short, are used for determining the names of the substances. You compare the one recorded in the book and that which you have found, and then it helps you to identify. All right, so the relative flow value is always less than 1. You must know that because the distance moved by a spot is always less than the distance moved by a solvent. That's very important. So how do you interpret relative flow values? The relative flow values can be used to identify the purity of a substance. Remember, chromatography can help you to determine whether a substance is pure or not. Chromatography on its own will form, if the substance is pure, it will form only one spot after chromatography. So this is the original, and this is one spot. That tells you that the substance is pure. But if there are several spots, let's say you have another spot here, let's say there's another spot here, different color, then it means that there are two spots. That means there are two substances formed. But in relation to flow values, a relative flow value which for a substance which is pure will only be 1. So we are saying a pure substance has only one relative flow value. If there are several relative flow values, it means that that particular substance is not pure at all. Like here, you see, this substance here has several relative flow values. You have 0.2, you have 0.2, sorry, you have 0.2, this one here is 0.2. By the way, we are going by the diagram, not according to here what is written. So this is 2. So to give you 0.2, then this is 6, or it's going to be 0.6. This is 8, it's going to be 0.8. Here there are several relative flow values. That means that the substance is not pure. But for a pure substance, you only have one relative flow value. An impure substance, however, will have more than one relative flow value. So they're asking an exam to explain how you can use chromatography to tell whether a substance is pure or not. There are two ways. One, if the substance forms only one spot on the chromatograph paper, it means that substance is pure. And two, if the substance has several relative flow values, it means that the substance is not pure. A pure substance will only have one relative flow value and one spot. All right, so thank you very much. I'd like to stop here. When we meet again next time, we are going to look at testing for water, ions, and the gases. This is going to be our next. It's going to be our next subtopic for experimental techniques. My name once again is Mr. Pochilora. Wishing you to see you next time. Bye bye for now. Don't forget to like the channel and also to comment, to say something. And what else you can do is to subscribe. So subscribe to the channel so that you don't miss anything. All right. Thank you very much.